Product rule. Find the derivative of the function below. This is a function, and for this function, we have two functions subjected to multiplication. This is the first function, and this is the second function. So two functions multiplying. As you can see, there's multiplication on the middle. So function 1 and function 2. We can call the first function u and the second function v. So these are the two functions, first function u and the second function v. So u is multiplied by v. So u times v. We apply the product rule because product means multiplication. Now, to find the derivative of this y function, we introduce the notation for differentiation. We say dy dx like that. This is the notation for differentiation. So two functions subjected to multiplication, we say dy dx is given by du over dx multiplied by v plus dv over dx multiplied by u, like that. This is the notation which we follow for the product rule. So to find the derivative of this whole function y, we have to differentiate this first part of the function. This function is known as u. You can actually write it as u is equal to x squared minus 3x, like that. So this function is given in terms of u. That is why we are saying for this first function, du dx, differentiating this function. Once we differentiate this function, we multiply it with the second function, v. Then we introduce addition and differentiate this function. This is the v function, so we say dv dx. We multiply this with the first function u, so dv dx multiplied by u. Let us follow the procedure. What is the derivative of this function? So to differentiate this function, we say 2 multiplied by 1, we get 2. Then drop this x like that. Then reduce this 2 by 1. So 2 minus 1, we get 1. Minus the power on x is 1. We say 1 times 3 is 3. Reduce this power on x by 1. So we have 1 minus 1, we get 0. So this will be x to the power 0, like that. This is du dx. So our du dx is 2x to the power 1 minus 3x to the power 0. So we multiply the whole of this with v. What is our v? Our v is 2x to the power 3 minus 4. So where there's v, we remove the v and do a substitution of 2x to the power 3 minus 4. Close parenthesis. Plus, let us find dv dx. This is our function v. To find dv dx, we follow the rule. So 3 times 2, we get 6. Drop this x, so we put that x. Now reduce this power by 1, we have 2. Then we have 4. This 4 is considered as a constant because it doesn't have an x, and the derivative of any constant is equal to 0. So the derivative of 4 should be 0. So we say minus 0, like that. Then we close. Now this is our dv dx, 6x squared minus 0, that's our dv dx. We multiply it by u. So multiply it by u. What is our u? Our u is x squared minus 3x, like that. That's our u. This is power 1. From this, we can simplify. We have 2x. So 2x to the power 1 is better written as 2x minus, then we have 3. X to the power 0 is 1, and 1 times 3 is 3. We close. We have 2x to the power 3 minus 4, close. On the other side, we simplify. We have 6x squared minus 0, we get 6x squared. Then open parenthesis, we have x squared minus 3x. X to the power 1 is better written as x, like that. Can we simplify this further? Yes, we can. So we multiply this and this. So to multiply these, we start with this 2x. So just get the 2x and multiply it with whatever is in this second pair. So 2x multiplied by this. So we say 2x to the power 3 minus 4, like that. Secondly, we have negative 3 multiplied by everything in here. So we say negative 3 multiplied by 2x to the power 3 minus 4, close parenthesis. On the other side, we don't need to struggle, just distribute over parentheses. So 6x squared times x squared. So we have 6 times 1, we get 6. And x squared times x squared, x to the power 4. Minus 6 times 3, 18. And x squared times x, we have x to the power 3. Let us simplify the other side. 2 times 2, we get 4. And x times x to the power 3, we have x to the power 4. 2x times negative 4, we have negative 8x. Negative 3 times 2, we have negative 6 and x to the power 3. Negative 3 times negative 4. So we begin with the negative times negative, we get positive. And 3 times 4, we get 12. Plus 6x to the power 4 minus 18x to the power 3. We can now identify the like terms. X to the power 4 exactly equal to x to the power 4. These are like terms, x to the power 4 and x to the power 4. We have x to the power 3 and x to the power 3 like terms. We collect them. So 4x to the power 4 plus 6x to the power 4. Then we have minus 6x to the power 3 and minus 18x to the power 3. We also have minus 8x plus 12 plus 12. We have collected the like terms. Now sum these. 4x to the power 4 plus 6x to the power 4. More like 4 apples plus 6 apples. We get 10 apples. And negative 6x to the power 3 minus 18x to the power 3, which is negative 24x to the power 3. So here we are not subtracting because 6 has a negative and 18 has a negative. The signs are the same, so it means we are supposed to add these numbers. Then lastly, we have negative 8x, which doesn't have anything alike, plus 12, like that. So we end here. We cannot simplify this one further because the powers are different. This is x to the power 4, this is x to the power 3, this is x to the power 1, and this is 12 with an x to the power 0. So this ends here, and this is our dy dx. Thank you very much for watching.